Now, we're going to talk about expansion chambers right here. This is an expansion chamber pipe, or most pipes that are used on two-stroke racing bikes. Now, when we get into expansion chambers, they aren't just made for looks, okay? They have what are called cones. We have a cone here. We have a chamber here. And we have a cone here. And figure the pipe like an echo chamber. Like it makes an echo from the inlet right here all the way down to here, and the echo comes back all the way to the top. And now I know that may sound weird, but that is how an expansion chamber power pipe works. All of this, every bit of these cones are designed to produce a certain power wave in the cylinder. It gives it a supercharged effect. What we have is your exhaust right here. This is where it starts, or right there. We have a wave which goes in milliseconds, okay? Now watch. It goes out through the pipe to the center of the pipe, which means it goes from here all the way around down to here. Okay, this happens in milliseconds. This is a sonic wave right here. Okay, as the pipe or as the wave reaches the end, which is here, right here, it returns all the way to the beginning. And all the pipe is determined on how fast that power wave or tuned length will happen. You can't just make one of these in your garage. Now, when we go into tuned length and everything of the pipe itself, a long wave duration spreads engine's power band, and short duration wave with high amplitude is best for maximum power. And they talk about exactly how to build one, but you can't actually build one because unless you're a mathematician and you have denominators, yes. Anyway, all these pipes are designed for different grades of power. But this book explains it just beautifully on how an expansion chamber works. That's why most motocross bikes have expansion pipes like this one. This pipe to me is worth $1,000 to me. Okay, because this is a supercharged effect to a two-stroke valve system, which is going to really haul ass. Okay, but this right here will explain some of the lengths, as you can see. Okay, we have L5, which is right here. We have A1 and A2, which are, this is A1 and this is A2. All of this is a sonic wave that comes this way, stops here, and comes back all the way to the end. And what it does is determines this will suck fuel or supercharge fuel from the exhaust, from the cylinder, and how it works and comes back and makes power. Now, if you can understand all this bullshit, then useful cotangents. Remember, this was in 1973. You had to do all this on a blackboard or get yourself Albert Einstein or whatever for the formulas for all this. And port timing. And then we go on to port timing, but specific time, but there is no mean port timing. And they tell you how to check your exhaust transfers, intake. This is top dead center, bottom dead center, exhaust transfer, intake, and how that works. And angle, area, time area combinations, disc rotary intake for go-karts, transfer L exhaust, piston port intake. Here's the space shuttle at Atlantis, one right here. But I think if you're not from MIT, you don't have a clue. And then area timing limits, port timing. And here's where your port timing must occur when crank pressure and resonant inertia ram pressure balance. Whatever the fuck that means. Anyway, this is a great book to understand how the crankcase works. How the reed valve works. The reed valves in 1972 worked, which were metal, but they aren't Boyson reed valve, which are today. Next video.